Hello everyone, welcome to this new lecture of Basic Programming and Modeling for Geoscientists. This lecture is about control flow, loops, and conditions. We are still currently in the first part of BP13, and we are getting familiar with basic programming. We have discussed the basic structure of a computer, we have discussed about programming languages, and we started the introduction to programming. We basically discussed a lot about vectors and data types. Remember, you learned the different data types, integer, floats, characters, and we have discussed about the different data structures, the arrays, the tuples, structures in general. But in parallel, we haven't been doing only theoretical things. We have been doing quite a bit of practical data generation and data visualization. So you created already some cool figures. And that's why we are not only working on the first third of the lecture, but we are somehow also progressing and reaching half of the lecture progressively. So we are making very good progress. You are making very good progress. For now, we need to learn how to use programming instructions to work with the data. We have used quite a few of them in the examples, but I'm going to give you a little bit more details about them. And remember, one of the aims of BP13 is to avoid this kind of situation. You don't want to get overwhelmed by actions that you need to repeat, so you need the computer to do the things for you. So you need the computer for you to work and to read, to copy, to process, and to write data. So you need to learn about the control flow. So control flow is what will allow you to avoid this kind of situation. Basically, you want things to flow under your control. And for this, you need to learn about loops and conditions. So let's start with the loop, and we will first discuss the for statement. So you often want to perform a task repeatedly. So you want a similar action to be repeated several times. And this is called, or the verb for this is to iterate. You want to iterate. You want to repeat the action. For this, you can use the for statement, which you've seen in some preceding lecture. And the for statement looks like this. You can repeat n times an action, so you need to define what n is. And the for statement will be contained within a block that starts with the for and ends with an end. Next to the for, you will give an index. And this index will vary within a range. Between these two lines, you have the action that will be repeated. So, to make the link with the preceding lecture, you will see that I here is an integer number that varies according to a range from 1 to n with a step of 1. Inside here we have a, and a is a variable. And on this side, that's the desired action. So here we are incrementing a by 1 every time we go around the loop. So for this, I recommend you to try typing these things. And for this, you can open a notebook. You know how to do it. This will help you to follow the lecture. You open a new empty notebook and you can type the code in there. So you can give it a try. And of course, you will get an error. What you need to do, if you want these things to run, you of course need to define what n is. And since this loop is modifying the value of A according to the preceding value of A, you also need to initialize A. So when you do these kind of actions, the computer cannot guess what you have in mind, so you need to initialize A. So the question is, after the loop, what is the value of A? I let you compute this yourself. So you often want to perform the similar action. For this, you of course iterate, and you can try yourself to repeat this little exercise. This is printing a character string 5 times, and it is including the number that varies here. So this is the counter or the index number of the loop. So if you want to try it out, please feel free. Just create a code cell in your notebook and give it a try. So another type of loop is when you want to repeat an action until a condition is met. So it could be, for example, repeating an action until a condition could be an external field, like the temperature is changing with time, and you want to repeat the action as long as the temperature is below 25 degrees. You don't want to, for example, go jogging if the temperature is 35 degrees. Anyways, so for this you can use a while statement. So the while statement starts with a while, ends with an end. Next to the while statement, you should give the condition for which the desired action here is going to be repeated. So here we have b less than b max. And this is actually a Boolean number. That is a condition. This action will be repeated as long as b is smaller than b max. And the action which we're doing here, we are incrementing b. So at each time you go around the loop, b will receive an addition by 1. And this action will be repeated until as long as b is smaller than b max. So it will loop as long as the condition is true. It will stop when these conditions turns to false. So when you want this to run, again, you can type this in your notebook. Again, the computer cannot guess exactly what you have in mind. So if you want this little code cell to run, you of course need to define what is the value of b max. And since we are incrementing b, we also need to know what is the starting value. So that's very important. And so here we've used one condition. For the stopping of the while statement, we use the condition strictly lower than. So that's simply the inferior symbol. But you can use a lot of different other conditions, and I give you a couple of examples. So there is the equality. If you want something to stop when b is reaching the value of b max, the equality is the sign equal, equal. The inequality, if you want b to be different than b max, so you can use the exclamation mark equal. You can combine things if you want the two conditions to be valid at the same time. You can use an AND statement. This is this symbol here. Twice AND. If you want either of the condition to be verified, you can use the OR statement. The OR statement is twice pipe. Then there is the larger and the smaller. You can also make it larger equal or smaller equal. So there are different ways to deal with conditions, and that's basically by using these logical symbols. So one simple usage of a condition or implementation of a condition is to use an if statement. So this is how an if statement is constructed. It starts with the if keyword, ends with the keyword and if you want an alternative condition, you can use the statement else. So here, if b is equal to 10, hello world will be printed to the standard output. Else, in all other cases, tschüss will be printed to the standard output. So you can give it a try. If you write this in a code cell in your notebook, first you will need to define what is the value of b. So if you set b is equal to 1, you will of course get tschüss, and if you set b is equal to 10, you will get the statement hallo Welt. So let's make an example of usage of a loop and an if statement. We will combine the two of them. Let's define an array of characters. So create a new code cell and type this vector of characters, A, B, C, D, E, F. Then we can loop over the entries of the vector letters and print them to screen. So that's the first thing you want to type in your loop. So let's loop over all the characters we have in the vector letters. So for I equal to 1 until the length of letters. So the length of letters is 1, 2, 3, 4, 5, 6. So it will loop from 1 to 6. And then you print the letter of position I. So it will print A, B, C, D, E, F. That's a basic usage of a loop. And now we will do something in addition. We will loop over the entries of the letters and find the position I of character E. So we are looking for E inside this vector of characters. And then we will print the position. So here's an example of a combination of a for loop and an if statement. So you loop over all the letters, but if letters of position I is equal to the character E, then you can print a statement that will return the index I. If you want the loop to stop after finding the character E, you can add the statement break, and break will get you out of this for. It gets you out of the loop. The same thing you can do with a while statement, of course, and it's going to be a bit simpler because the while statement by nature includes a condition. So you can simply do set I is equal to 1 initially and then construct your while statement, let it run as long as letters of position I is different than character E, it will loop. If not, it will stop, and the value of I will be the index. So it will go 1, 2, 3, 4, 5. Now it finds that the letters I is equal to E, so this condition is not valid anymore. It gets out, and the value of I is the value of the index. A last example would be the element-wise sum So create a new code cell and make two arrays, x1 and x2, of size n. So you create one array full of 1s and one array full of 2s. And we will make the sum of these two arrays. So array 1 can be represented by this. So x1 has x1 of position 1, position 2, position 3 until x of position n. We have a second array, x2, with the same entries but different values. And we are going to make the sum, the element-wise sum of these two arrays, to be returned into a vector y. So y1 should store x1 of position 1 and x2 of position 2 until the end. Y of position n should contain x1 of position n plus x2 of position n. So what needs to be done is, of course, to allocate memory for x1 and x2. You start the loop for I equal 1 to n, and we can try to type y of position I is equal x1 of position I plus x2 of position I. And this, you will quickly realize that you also need to allocate memory for the vector y. So you need to add one line, y is equal zeros of n, if you want this to work. So the question is, are there any alternative ways of doing this? And the answer is, of course, yes. We did use already some alternative way of computing this sum or any other kind of element-wise computation, and that's called vectorization or broadcasting. So again, the same operation, it can be done only in one line by vectorizing the sum. So again, you allocate the vector y if it's not done yet, and then you can make y point equal x1 point plus x2. So in this case, you write everything in one line. You don't see the index anymore, but each operation needs to be preceded by a point. And the arrays must have the same size, of course. So it's quite convenient because it's only a one-line statement, and you basically don't see the index. It's a bit more compact. So these are two flavors of programming, and both of them are correct. In some languages, this type of programming is much more recommended. For example, in MATLAB or in Python NumPy, it makes code faster than using loops. But not every operation can be broadcasted. So it's good to know about both styles of programming. So that's the end of the lecture. We've discussed about the for statement. We discussed about the while statement and the usage of conditions inside the while statement or using an if statement. And we have seen a couple of examples of usage, the search and the element-wise sum as examples. Thanks for your attention.